আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।
কেমন আছেন স্যার?
তো আলহামদুলিল্লাহ ভালো। আপনারা সবাই ভালো আছেন?
জি স্যার, আলহামদুলিল্লাহ ভালো আছি। একটু ওয়েট করি স্যার, 2-4 মিনিট। স্যার, আমরা স্টার্ট করি।
Okay, okay. So now we'll start. So now can you see my screen? Can you see my screen?
ইয়েস স্যার, দেখতে পাচ্ছি স্যার,
আচ্ছা,
এভরিথিং ইজ ক্লিয়ার।
so okay. So, hi and welcome. to the 7 days online training program on Google Earth Engine for beginners to advanced level on Google Earth Engine. So we already cover our first day and second day. So today is our third number of class. So basically, this is our full course content. We will try to complete it all of the contents within the 7 days. And today is our third day. So basically, third day, I will try to discuss about this Sentinel-2 satellite imagery, how you can easily filtering and displaying the satellite images. And after this, how you can easily monitor the NDWI or normalized difference water index. And previous class, I also try to show you this part for the Landsat imagery. So Landsat 8 imagery, how you can easily filtering, then how you can easily export the Landsat 8 imagery, and also how you can easily export the NDVI map. Okay, so all of the things I also try to discuss. So today I will try to discuss about this part, how you can easily filtering and displaying the satellite images, mainly Sentinel-2 satellite images. And after this, how you can easily monitor the NDWI using these satellite images. Then how you can easily make that NDVI time series chart. Okay, previous class we also tried to show you that how you can easily make the NDVI map, but we did not cover the part for NDVI time series chart. So we also try to complete this part. Then export any shape file, how you can easily export. Then calculating any indices from the satellite images. Then how to add the gradient legend. Then how to monitor the land surface temperature monitoring. Then NDWI calculated from the MODIS and Landsat data. Okay. So first of all, filtering and visualizing the satellite images. So the same process, we already covered this part in the Landsat. When you want to filter the satellite images, it can be Landsat or Sentinel, both of satellite images. We have to filter some factor. First factor is that you need to select your region. Suppose you want to work with need the Sentinel-2 satellite imagery for the Dhaka city or Dhaka district or any other region. So first of all, you have to select your region of interest. Then you also need to filter the image metadata or image properties. Suppose I want to need only for those images, which image will be not more than 1% cloud cover. So this is the one kind of image properties. I want to need less than 1% cloud cover images. And we also need to filter according to the specific time period. Suppose I want to need the satellite image for year of 2017 rainy season, 2017 dry season, monsoon season, or any time period. When you want to filter these satellite images, we just follow the 3 factors and filter the Landsat, Sentinel, both of satellite images. So in this time, I try to show you that Landsat 2 satellite images, and after this, how you can easily make the NDWI map for monitoring the water on the surface. Okay, so let's go. So I just simply open my code editor. So I simply open a new code editor. Okay, so first of all, I need to import my boundary shape file. And first class, we already covered this part, how you can easily import your boundary shape file. So here I already imported the boundary shape file of Dhaka city. I want to work with the Dhaka city region. So first of all, I simply import the Dhaka city shape file. So from the asset tab, I can easily find out all of the boundary shape file. So I already imported the shape file in the asset tab. So in this time, I just simply Dhaka city. This is my shape file. You can see this shape file. Suppose this area I want to need the Sentinel-2 satellite imagery any time period, dry season or rainy season. Okay. Then you can say I simply click the import. Now it is the imported. It's the default variable name table. If you want, you can change it or not. It totally depends on you. I simply change it and put the name, suppose ROI. You can use any name. I want to show this shape file as a layer on this map. So I simply add the function map dot add layer, and then I simply object name is that ROI. I simply put the object is the ROI because this variable is stored in my shape file. I click to the run. You can see a layer will be added, but I did not see my area. So for this, I simply use that the map dot center object, and then use there the ROI and use there the 10 and click to the run. So now you can see I can get my area. Okay, so this is my region. Suppose this region I want to need the satellite images for a 2 time period. I want to need the time period for the dry season as well as also wet season. Okay, for the 2 time period I need the satellite images. So in this time I just simply okay. So in this time in this for this region I want to need this satellite image for a dry season as well as also wet season. Okay, so for this I simply filtered this satellite images, and which satellite images I need to import the satellite images. I simply go to the browse data catalog and then find out the Sentinel-2 satellite imagery. Okay, you can see Sentinel, simply click to here. And then you can simply the Sentinel-2 multi-spectral instrument, simply search, click here, or if you want you can simply search here. Suppose I simply search the Sentinel-2. So now I can get this multi-spectral instrument level 1C. I simply click here. Now I can get all of the information about the satellite images. You can see. So basically, this satellite images is the multi-spectral instrument, and all of the band you can see. It has the all of the band we can get. Okay, so in this time I want to use these satellite images for make the NDWI map. So first of all I need to filter. So I simply import this. It will be imported. You can see it the default variable name is the image collection. If you want you can change it. So I simply change the name and put the name, suppose can use any name. I simply put the name, suppose Sentinel 2. Okay, so now you can see it will import it. This image collection I need to filter according to the 3 factor, same as Landsat 8 image collection. So I simply take a variable. Suppose this variable name is that, suppose you can put any variable name. Suppose I put the variable name is the dry image. Suppose I want to need filter the image for the dry season. I put the name dry image. You can put any name. Then I simply call this image collection Sentinel-2, because this variable is stored my all of the Sentinel-2 image collection. It is stored in this variable. I simply copy and paste here. Paste here Sentinel-2. Okay. In this time I simply use here the filter bounds function. Filter bounds. Then I simply filter bounds according to my region. Okay. So you can see it argument is a geometry, and my geometry is that my boundary shape file. And what is the boundary shape file? Boundary shape file is stored in a variable. This variable name is the ROI. I simply put here the ROI. Okay, in this time I use here this ROI, and in this time I also need to filter my specific time period. I simply use here the filter date and put here the start and end date. Okay, so suppose I want to need this dry season image for year of 2020. Okay, so 2020 1st January from 2020, I put the name, suppose 0 April from April 30. So I put this dry season time period success. In this time I want to also need to filter this image specific properties. Suppose I need this satellite image less than 1% cloud cover. So I simply use here this filter metadata, and you can see I need the name, operator and value. So I simply go to this image information sheet. Okay, so I simply go to this image information sheet. From here you can see I want to get the image properties. I simply copy this property name, cloud pixel percentage. So I simply put the name, so cloud pixel percentage, and then operator less than. So I simply put the less than, and put the value is for 1. Okay, so I need the satellite image less than 1. Between this time period I need the satellite image, which image is the less than 1, I will need this satellite image. So I simply filter according to the cloud pixel percentage less than 1. After this I also need to filter I simply use there the median. All of the images I want to create the median composite, and also clip with my shapefile. I simply use there the clip. The shapefile is that ROI. Okay, and to show this image I simply use here the map.add layer, and then simply call the dry image. This is my object, and paste here and click to the run. So now you can see this image is added to our boundary. Okay, but it's showing as a black color because I did not add any visualization. So in this time I want to add here the band visualization. I simply click to here and then I add here the band such as red band, then also add here the green band, then also add here the blue band, 3-4 3-2, 98% for better looking. Then I simply apply. So now we can easily get this 4-part satellite images in, okay. So I can say I can get this satellite images in here, okay. And this is satellite image cloud cover is that less than 1% cloud cover, okay. And this satellite image is the dry season satellite image because I want to put this time period as a dry season. So in this time from this dry season, all of the image which is less than 1% cloud cover and created the median composite. If you want to work with a single image, so then you can simply, we already discussed about in the Lancet part how you can easily work with a single image. Suppose I also try to show you again, just a minute. So I simply commenting this line. Suppose in this time I want to check how many images I want to get for the region of Dhaka city. I simply print this and call the dry image and paste here and click to the run. I want to get all of the information about this, all of the image you can see. I want to get total 20 images in here. So you can check from the feature, you can see all of the images I want to get, okay, all of the single images. Suppose you want to work with a single image, just copy this ID name and then simply use here the e.image function, the same process on the Lancet, okay. So in this time I will not showing this part, so you also try to work with a single image. And in this time I use the median composite, so I simply use here the median and then try to click to the run. I can get the images, okay. So in this time you can see I get the images, and when I click to the run, again it's showing as a black color. It's showing as a black color. In this time I did not set the visualization in my code editor, so that's why I can get the black color again. So I simply click to here, and then in this time it says set the visualization. So I simply use here the B4 as well as also add here the B3 as also add here the B4 and B2. So custom 98%, and then apply. After apply I need to click to the import. You can see when I click the import, a new line of code will be added in here. I just simply copy this variable name from here and then paste after the object name. So this is my object, this object name I simply paste. And click the run. Okay, so you can say I can get this in. Okay, so now you can see now this visualization is set it with my code and I can get this proper satellite images. Now if you want to export this image, the same process for Lancet. First of all you need to select the band, so you can simply use here the select function, then you can simply select all of the band which you want to export and you can easily export this. The same process the follow the Lancet 8 satellite images. So in this time you can say I can get the satellite images for the dry season. So in this time I also need the satellite image for the wet season. Okay, so for this I use the same code. I just simply copy the same code, and after this I simply paste in here. Just I change the variable name. Suppose I put the variable name is the wet season, wet image, okay, and I simply define the wet season time period such as it will be start from such as June and from October, okay, and so then I simply copy and paste here, okay, then click to the run. So now I can say I can get this satellite image also wet season. Okay, in this time you can see I also get the satellite image for the wet season. So in this time I also add the layer name, so then it's better. So for the layer name I simply add the layer name. Suppose this is the dry image or dry season image and the wet image, and click to the run. So now you can see I can get these two time period satellite image here, wet image and dry season image. the wet image, there is a no cloud. But when appear at the wet season or rainy season image, here you can find out the some cloud on our satellite image. Okay, the cloud. But in Google Earth Engine platform, we can easily remove all of the cloud and haze from the satellite images and then get the clear satellite images for any time period, dry season or rainy season. So you can see there is a lot of cloud. So basically, cloud is hampered when you want to make the land use land cover classification map. Suppose in this time you want to need this image for making the land use land cover classification map. Then you can see this white cloud. This white cloud has a some pixel value. This white pixel value is similar to the barren land as well as also similar to build up area. So now when I classified, this cloud is also showing as a barren land or also showing as a build up area. So that's why when you want to make the any types of land use land cover classification map, first of all you have to remove all of the cloud and haze from your satellite images. Then you can use the satellite images for making the land use and land cover classification map. Otherwise you did not get the proper result or proper land use land cover classification map. In Google Earth Engine platform, all of the cloud we can easily remove using the cloud marks band function. Okay, so in this time I will not show you the land use land cover classification map. So I show you only for the index of the NDWI. So NDWI is only for the two band, near and green infrared band. So that's why we did not remove the cloud. Without removing the cloud, we can get the proper result for the NDWI. Okay, NDWI that is not hampered when you want to make the any type of index or other things. It's not, this cloud is not hampered. But when you want to work with the land use land cover classification map, it must be hampered and you will not get the proper result. So in this time and next class I also try to show you this part how you can easily remove the cloud. Suppose you can see a lot of cloud, also a lot of cloud, but we can easily remove all of the cloud and haze from the satellite images using the Google Earth Engine platform, and we easily get the clear image like this dry season image. You can see there are no cloud. So we can easily remove the cloud marks function and we can easily get this type of clear image. This image is totally clear when I use the cloud marks band function. So next class I also try to show you this part how you can easily remove this type of cloud and get the clear satellite images. So in this time I get the satellite images, wet image and dry image. In this time I want to identify on the Dhaka city surface for the two time period, wet and dry, what is the condition of the water. What is the condition of the water on the Dhaka city surface. Mainly basically we can get the lots of water body in the wet season or rainy season, and we can get the very low low area of water body in the dry season. But in this time we also just monitor using the satellite images. So let's go, and we are using here the NDWI. So first of all we should know what is the NDWI formula. So lot of index is available for extraction or identify the water body on the surface. I want to use here the NDWI. So NDWI. So I can simply go to this name. And if you want to know the more details about the NDWI, you can simply read this paper about the NDWI. Okay. So in this time I just calculated the NDWI. Okay, they are the okay. So you can also try to open another. So you can see the formula for the NDWI. When you want to use the Landsat 7 image, you can just put this equation, you can get the result. Band 2 minus band 4 divided by band 2 plus band 4. Because band 2 and band 4 for the Landsat 7, it's the green and near infrared band. Okay. So band for the Landsat 8, band 3 is the green and band 5 is the near infrared band. For the Sentinel 2, band 3 is the green and band 8 is the near infrared band. Okay. So then we can, this is our main formula, green minus near divided by green plus near. Okay. And then we can use the NWI for getting this, what is the condition of the water. And there's a lot of uses for the terrestrial vegetation, soil feature, soil moisture. So all of the things we can easily identify using the NWI. You can see this is also following the rains. Okay. NW application. So all of the details you can read from this website. Then you can easily identify how we can use the NW index. So in this time, I just follow this equation and try to develop the method and calculate the equation or identify the water surface on the Dhaka city's ground. So I simply okay. So this is my code. So this is my equation. So in this equation, you can see I need the two band, green and near infrared band, or green plus near infrared band. Okay, so in this time, I want to calculate the equation and then calculate the NWI. So for this, I just simply take a variable. There are a lot of way for calculating this type of equation. I simply take a variable and give the variable name is the suppose NDWI, suppose dry season or dry NDWI. I want to calculate the NDWI for the dry season image. So in this time, I simply call the dry season image. So you can see this is the dry season image. So all of the things for the dry season and all of the things is stored in this variable dry image. I simply copy this and paste here. Okay. So after this, I can use the lot of method. But in this time, I simply show you the easiest method. Easiest method is that normalize difference. So this is the built-in function in Google Earth Engine platform. So you can see normalized difference. So this is the built-in function. Mainly when this is the normalized difference function. When you use this function, it automatically calculated this type of equation. Okay. So in this time, I simply copy this and try to discuss a lot of things about this function. I simply paste here. You can see this function computes the normalized difference between two band. When you want to compute the normalized difference like green and near infrared two band, only for the two band, we are using the normalized difference function. And it computed as a first minus second divided by first plus second. Okay. So you can see green minus near infrared band divided by green plus near infrared band. So in this time, I need to define here the first and second band. So what is the first and second band? I simply make a list. First band is the green, and green is for a name is that you can see, check the name also. What is the green name? So you can see the bands and check the band. You can see green is the B3. And what is the near infrared band? You can see near infrared band is the B8. Okay. So B3 and B8. So green minus near. So first band is that B3. Second is that B8. Okay, so this is my band. So now it computed is the B3 minus B8 divided by B3 plus B8, such as this type of equation, because I directly use the built-in function. This function algorithm is look like this. It's computed as the first minus second divided by first plus second. Okay, this type of equation. Okay, so in this time I also need to calculate NDWI for the wet season image. So I simply copy the same code. I just simply copy and paste here. And then I simply call the wait image and paste here. Okay, and also change the variable name, suppose NDWI wait. Okay, then in this time I want to show the result. So in this time I show the result such as I simply use here the map dot add layer, and then I simply call the NDWI dry image. I want to first dry and paste here, and then I simply make the color plated. So I simply make a list dictionary. In this dictionary, I simply put here the mean value. It will be start from the -1 and up to, suppose I want to add the max up to suppose 0.5 or 1. But in this time I need the result for this range -1 to 0.5. If you want, you can also use the 1, no problem. In this time I simply use the plated function for showing the different types of color. I want to make a list. So I simply make the square bracket and put the color. Suppose I use here the red, then greater than red pixel. I want to show the suppose yellow. Then I simply use there this suppose green color. Then I simply put there the another color, suppose water body. I want to show as a green color. Okay. So I simply put the color and also put the layer name. So the dry NDWI. Okay. I simply copy and paste here again. In this time I just simply change the copy the variable name and paste here, and also change the layer name, suppose wait NDWI, and click to the run. So now I can see it also added the another 2 layer. So now I can see the result if we are it. So now I can get the result. Okay, so if you want to show the proper visualization, then you can simply click on inspector tab and click on the any water body. Suppose this is the water body, simply click to here. I can get the value. Suppose I can get the value, you can see. I can get the value, you can see. The dry NDWI, I can get the 0.1, but when it's showing the wet NDWI, it's the 0.2. So basically, NDWI, this high positive value, I identify the high water. Okay, so basically in this time, you can say I can get the 0.2 for the wet NDWI for the wet season, and I can get this for the region 0.1. Okay, so this is the two types of water, but wet season we can get the increasing the value of the NDWI pixel value increasing than dry season image. Okay, so I can simply click here, you can see. So I can see 0.3, but I can see for the dry NDWI you can get the 0.1. So it's also increasing. So basically wet season or rainy season, for the rainfall we can get this type of large of water body or lot of water body in the earth surface. Okay, so in this time we can get the Dhaka city. You can suppose in this time I simply copy this value and then try to paste here. Also try to paste here. So run. Okay, okay, so basically in this time this visualization is not important, because in this time when you want to export this image and upload import this image, export this image and import in the ArcMap software, then we can get easily all of the pixel value. We can easily get in ArcMap software for the high and low. Okay, we can easily get this, and then we can easily, from the symbology of the ArcMap software, we can easily add the our own color. Which color you want to use, you can simply add this color. So in this time I simply click the run. In this time, which range I want to select in here, it only showing this pixel value. Okay, so now I can see I want to show this green color as a blue color. So I want to just okay, okay. So I can use the green two type. So I simply change this. So I simply mistake in here. It will be blue color too, and also use here the I type the green two times. So that's why it also showing as a water body is also showing as a green color. Now check the result. Not showing it. 0.5 we can take the value. Okay, now I think okay. Now I can check. We can easily identify what is the difference between the wet and dry season. I can see this is the wet season image. You can see satellite image. So very few water body or water surface on the Dhaka city. But when I open the rainy season image, you can see there is a lot of water body or water surface. It will be increasing. Okay, so this is the difference we can get. And high NDVI value, high NDWI value identify the high water frequency. You can see when I click here, I can get this NDWI value for the wet season. You can see it will be showing dry season there is no water, but I can find out the wet season there is the lot of water body. Okay, but dry season there is a totally there is no water. So negative pixel will identify there is no water. Positive will identify there is the water. So you also read this from this link. You also try to read this. Then you can easily understand what the value identify, high positive value, high negative value, what type of feature identify. You can easily understand. So in this time, anyone any question in this code? Anyone any question? Anyone any
No
question?
question, sir.
Okay. Okay. So in this time, if you want, you can easily export the same map. Such as suppose you want to export this map, the same process. You can simply export image drive, and then you can simply put all of the argument one by one. So I simply make a dictionary. I use there the curly bracket start and curly bracket in. So first of all, image. So image. Suppose in this time I want to export the image for the dry season or wet season NWI. First of all, you can see there is a total 3 or 4, total 5 layer. I want to export this suppose wet season image. This wet season image is stored in a variable. You can simply put this variable name. This variable name is the NWI wet. I simply copy and paste. Okay. Then description can be anything. You can simply put the description such as you can put any description. So I simply put the description as the NDWI wet season. Okay. Then you can put the folder. You can put any folder name.